This problem, it says we have a meter stick. I have a meter stick right here. And it says a meter stick is rotating with a constant acceleration of 10.5 radians per second squared about an axis that passes through one end of this stick. So it's like me swinging it like this. I'm swinging it from one end. So the thing is, the angular acceleration for the entire stick is going to be the same. The tangential velocity is going to vary based on how close I am to where I'm holding it, which is the axis of rotation. And they tell us what they want that amount to be. So we have, it says it's rotating with a constant angular acceleration of 10.5 radians per second squared. And then it says we want to know where on the stick would the tangential acceleration have a magnitude equal to that of the acceleration due to gravity. Well, what is the acceleration due to gravity? What is the magnitude of the acceleration due to gravity? What? 9.8. So our A, we want it to be 9.8 meters per second squared. And that's going to be at whatever the R is from the axis of rotation. So the unknown is the R. So those are your facts. The formula when you're involving both angular and tangential together, then we're going to use one of our three formulas that link those. And the one with acceleration is that A equals R alpha. So that's our formula for that. So again, I'm doing it like a four-step problem, but there's not a lot here. Step 3, solving for the R. And the R then would be A over alpha. If we plug in the numbers, we're going to get R equal to, for A, we're going to get 9.8 meters per second squared. And for alpha, we're going to get 10.5 radians per second squared. I actually changed this problem. At one time, this number right here, I had as a number less than 9.8. And if that number was less than 9.8, then that would mean that my R would be bigger than a meter. So I wouldn't even have a place on the meter stick where the acceleration could possibly equal that value. So I increased the size of this just so that I would get a number less than 1. And if you solve that, what do you get for the answer? 0.93. To 3 significant digits, you know, or is that the number that I gave you? 0.933. And I write it as meters, but if you look at the units here, it looks like it's meter per radian. The second squareds will cancel out, meter per radian. But like I told you, we're going to ignore the radian. What that does is that allows us to go from something that is angular to something that is or rotational to something that is translational or tangential. All right, any questions with that? All right, so that was under 4 minutes.